Welcome to Mechanical Drawing and Design N6. Today's presentation is going to be on pulley and gear wheel design. Before we get into this module, I do need to say that if you haven't done the module on belt drives and the module on spur gears and gear drives, I will advise you to first begin by going through those two modules before you look at this one. The reason for that is because in this module, we glean on the knowledge from those two modules. So if you haven't done those two modules, you will find this module to be more difficult than it really is. I do know that in your textbook, this module comes before the module on spur gears and gear drives. However, it is more practical to teach belt drives and then to teach spur gears and gear drives before teaching this module, because this one is actually gleaning on the knowledge that you have from those two modules. So if you haven't gone through those two modules, I will advise you to go and do that first before you actually look at this module. I have videos on those two modules, so go and watch those videos before you actually watch this one. Let's begin. And so we will first begin by talking about the geometrical properties of pulleys and gear wheels. At the bottom of the screen here, you will see that I have labels and their meanings. And the reason I like to put that at the bottom of the screen is just so that when I am explaining, if ever you wonder what is the meaning of a certain label, you can just read at the bottom of the screen and you will know what that label actually is. And so first, let us look at a pulley. So what you see on the screen here is a pulley, and you can see that this pulley has four arms. Okay, these are the arms of the pulley, and you can see that it's four of them. And so sometimes instead of saying arms, they may refer to them as spokes. So it's all the same, okay? Whether it is said that it is a spoke or an arm, it's the same thing, okay? So this pulley here has four arms, as you can see. You can also see the rim of the pulley, okay, which is this shape, this circular shape here on the outside, okay? This is the rim of the pulley. And in the middle, you have the boss, okay, or the hub. Okay, so the most common expression is actually the hub, okay, but for some reason in your textbook they refer to it as the boss also, okay, so but the most common expression is the hub. And so with that, then I can also introduce to you the shaft, because the shaft is designed to fit in a inside of the boss, okay? The boss has a cut inside for the shaft to fit in. And not only that, you also have a cut for the key, okay? You can see here you have a circular cut in the boss for the shaft, and also you have a small cut that protrudes in this direction, in this case, for the key, okay? I hope you can see what the key is. Very important. And this, of course, is a pulley, so you can see that you have a belt wrapped around the pulley. And at the bottom, you have the tight side tension, which is T1, and on top, you have the slack side tension, okay? And so these are the important parts that you need to know on a pulley. And now let us look at a gear wheel. And this is a gear wheel, and again you can see that this gear wheel also has four arms, okay, or four spokes, and these are the arms of the gear wheel. You can also see the rim is here, okay, that's the rim, okay, and you have the hub or the boss, which is what you have in the center here, this cylindrical shape in the center, and in the boss there is a cut for the shaft and also for the key, okay? So in the center there, it's the shaft that will fit inside there, and you have a space for the key, just to make sure that the shaft is held nicely into place, okay? Very important. And so let us look at some of the geometrical properties that will be of interest. The first one is that of the hub or the boss. The diameter of the boss is equal to twice the diameter of the shaft. So if you get a question and you are given the diameter of the driving shaft, then it's very easy to get the diameter of the boss. You just multiply that by 2. And then you also have the length of the boss, and that is equal to 1.5 multiplied by the diameter of the shaft, okay? Now the length of the boss cannot be seen in this picture here, okay? And the reason for that is because it runs into the page, okay? It's the length that runs into the page. And as you can imagine, the length of the boss will have to be equal to the length of the key, because the key is a cut that is made in the boss, okay? So it runs through the length of the boss, and therefore the length of the boss must be also equal to the length of the key. The second thing that we're going to focus on is the rim thickness. And the rim thickness, when you look at this pulley here, this is the rim, and of course it is circular. And so the thickness is that length here. That is the rim thickness for the pulley. And so I will refer to that as TP rim to say the thickness of the pulley's rim, okay? And the equation for that, the thickness for the pulley's rim is equal to 0.01 multiplied by the diameter of the pulley, and all of that plus 3. But you need to be careful when using this equation. The value for the diameter of the pulley that you plug into this equation must be in millimeters, okay? Because this is an equation that gives you an answer in millimeters for the thickness of the pulley's rim. And therefore, the diameter of the pulley in this equation must also be in millimeters. Very, very important. And then you also have the thickness of the gear rim, okay? The gear wheel's rim. Okay, and that is that length there, okay? That's the thickness of the gear wheel's rim, okay? That length here. And the equation for it is 0.5 multiplied by the circular pitch, okay? So P here is the circular pitch, okay? And this is something that you know already from the module on spur gears and gear drives, okay? So the thickness of the gear wheel's rim is equal to 0.5 multiplied by the circular pitch. That is very, very important. And then we can speak about the pulley's width. And if this is our pulley, okay, that distance there, okay, that is what we refer to as the pulley's width, okay, and I will use the label W pulley to say pulley's width, okay, and the equation for that is that the pulley's width is equal to 1.05 multiplied by the belt's width, okay. W belt is the belt width, okay, very, very important. And then we also have the crown on flat belt pulleys, okay, because of course when you're dealing with flat belts, sometimes the pulley will have some level of crowning. And what is meant by crowning is this, okay, so this is the pulley, okay, I hope you can see the picture here. This is the pulley, okay, and so you will see that on the top surface of the pulley you have some level of crowning, okay. When the surface of it is made like this, then the distance between the topmost surface of the pulley and this point here where the crowning stops, that distance here, that is what we refer to as crowning. And the reason a pulley is done like that or designed like that is to make sure that the belt remains in the middle when the pulley is spinning. So you can either have crowning like this, or you can limit the movement of the belt by having like protrusion, okay, or extended surfaces like this, like what you can see on this pulley. This pulley doesn't have any form of crowning, but they pretty much protruded the surfaces on the edges here. Okay, so this surface is protruded and the one there is also protruded, so that the pulley so that the belt can rest nicely in the pulley. Okay, so when you have it like that, then of course you do not need to have crowning, because there is no fear that the belt will fall off the pulley. But if you do not have these brackets, as you see on this pulley, then you're gonna need to have some level of crowning, because once you shape your pulley like that, this shape actually makes it's impossible for the belt to actually fall off the pulley, because as it spins, if ever it tries to move to the side, it will then be redirected to the center. Okay, it may seem to be a bit counterintuitive, but it is actually what happens in real life. This shape prevents the belt from falling off the pulley. Okay, so very important. And so this crowning here is what we refer to as CR, and this is what CR is. So CR, the crown, is 2 millimeters if you have a pulley that's got a diameter lower than 250 millimeters. Okay, so if the diameter of the pulley is 250 millimeters or lower, okay, then the crown is 2 millimeters. If the diameter of the pulley is between 250 and 400 millimeters, then the crown of the pulley is 2.5 millimeters. If the diameter of the pulley is 400 millimeters, is greater than 400 millimeters, then of course the crown will be 3 millimeters. Okay, very important. These are just some geometrical properties that you need to be aware of in order for you to successfully solve problems from this module. And so, continuing with geometrical properties, again, looking at the bottom of the screen here, you can see I have some labels and their meanings, and these are things that you are already familiar with. And so what we're going to look at now is the arms cross sections. Okay, this is very important, because in the design of pulley and gear wheels, one of the things that you need to be able to design is the cross section of the arm. Okay, not just how long the arm is supposed to be, but what is the shape of the arm when you look at its cross section. Okay, and so this is what we're going to look at very quickly now. Now let us begin with arms that have a rectangular cross section. But first of all, what do I mean by the cross section of an arm? So you can look at this here. Okay, what you can see here, I took the example of a gear wheel, and you can see you have the arm of a gear wheel in this picture. So if we cut it there, okay, if we take something very sharp and we cut the arm there, and then we look at the surface that we see after cutting, looking in that direction, the shape that we will see, that is what we refer to as the cross section of the arm. Okay, and so if that cross section is rectangular, okay, with dimensions like this, okay, the height of the rectangle is b, and the width